Good evening, everyone. My name is Sabad Modi, and I'll be presenting to you my project NanoGen, which its main goal is to generate clean electricity at low costs. Essentially, what our project aims to solve is the UN United Nations Sustainable Development Goal number 13, which is about climate change. So we know as of today, carbon emissions fuel climate change, and they cause various devastating effects such as temperature rise, extreme weather, and ecosystem disruption, and a lot more. Due to this, communities, especially marginalized ones in India or in Africa, suffer without electricity, and they affect extreme climate effects such as food shortages and health risks. And this is essentially why sustainable electricity is extremely vital to help fight climate change and help these marginalized communities. And this is why we developed our solution NanoGen, which uses shadows or contrast and light to generate electricity. Let's quickly go over our solution and an animation. So here we can see a normal shadow electricity generator wafer, which is also commonly known as the SEG. So here we can see there is a normal wafer with a 50 nanometer gold film and an N-type silicon and a shadow casting object. We can see electrons are present all over. When sunlight is incident upon the sunlit area or the non-shadow area, we can see electrons present in that area get energized. Due to this, electrons move and they go to the concentrated to the side where sunlight is incident, and electrons get concentrated over there. Due to this, there's a difference between the number of electrons in in the non-shadow area and the shadow area. Due to this, current starts flowing, and this is essentially what we aim to harness: the difference in electrons due to which current flows. Let's compare NanoGen to other present alternatives. NanoGen works 24/7. It's extremely low cost, and it works in all environments, whether it's raining, whether it's sunny, or whether it's day. Right? Solar energy, however low cost it is, can only work in the day. Cannot work without the presence of sunlight. Piezo and power electricity can work 24/7, but are extremely are not low cost. They cost a lot, and hence they're not feasible for especially in the marginalized communities. We can see three different designs here. One is a common SEG wafer, which is the first design. Our second design basically removes the or eliminates the need of a shadow casting object. It uses the same SEG wafer um, multiplied to each other, connected in series, which acts as a shadow casting object for the previous one. And this multiplies the output and also eliminates the need for an external object. Our last design basically increases the frequency of the intensity of light using mirrors to concentrate light in a central area, um, or in the central area of the sunlit area. For our output, we can see our first design generates about 92.34 microwatts. This has been tested in the lab by NUS researchers, and we've gotten this output from there. Our second design generates about 161 microwatts, and this has been estimated and calculated from the data points we've gotten from the first design. It has several different applications in the real world, but as of now, currently it can power a 1.2 volt small watch, and hence the SG as of now in the current stage can be used to power small appliances with minimal power. SCG cost extremely minimal has extremely minimal cost, which is just under $10 for a 36 into 18 centimeter panel. It uses extremely few items such as a 50 nanometer gold film and an N-type silicon wafer, which is extremely cheap, not too costly. We believe that NanoGen has an extremely high growth as solar energy started same as if a worse start with even fewer power output in the 1990s, but today is one of the most used and highly adopted sources of energy, and hence NanoGen we believe the next 20 years can grow due to the advancements in semiconductors and in computing powers and in scientific awareness. Our product cycle is we go for development to testing and then and then go back to development to improve for what we found in testing. Go to validation. We go to validation. Go back to development, and then we commercialize it finally. Our next steps are improving and testing and optimizing a material, maximizing a power output, enhancing designs, and testing it in lab conditions. We believe NanoGen is the future, and I hope you do too. Thank you.